Welcome back, Algebra 1 students. Today we're going to look at section 2.4, solving equations with variables on both sides. Now early on I think you'll find that the majority of the things we do would be things that make sense and things that you possibly could have figured out even without this lesson, but we're going to run into the weird situation at the end, and the last slide on this video is actually not included in your notes, so you'll need to make sure and write that down carefully. You have plenty of space on the back of your paper. Alright, so to solve equations with variables on both sides, we take the same approach that we did with any other equations that we've solved in the past, which is use your inverse operations and your properties of equality. So here we go. Number one, 4x minus 24 equals 8x. In order to get the x isolated, I'm going to go ahead and subtract 4x from both sides. That's going to leave me with a negative 24 equals 4x. And then by simply dividing by 4, we can get our solution of negative 6. Piece of cake. Alright, let's take a look at the next one. Now you can see we have a variable term on both sides, a 4x and a 3x. We also have a constant term, a 6 and an 8 on both sides. So we have a decision to make. Do we want to move the variables to the left, or do we want to move the variables to the right? Honestly, it doesn't matter. I'm going to make a choice and just move my variables to the left. So I'm going to start by subtracting 3x from both sides. So I'll have 6 minus 7x equals negative 8. Now to get the x by itself, we can subtract 6. Gives us negative 7x equals negative 14. Then we can divide, and x would be 2. All there is to it. Alright, why don't you pause this video and try number 3 on your own. Okay, I'm back. Now hopefully what you did on number 3 was started by distributing the 4. So 4 times 2 and 4 times negative 8x. 4 times 2 is 8. 4 times negative 8, or excuse me, negative x gives us a negative 4x. Again, we have that choice to make. Do you want to move the variables to the right or the left? I'm again going to move them to the left. At this point, we need to continue working to isolate the variable. So adding 7 to both sides using the addition property of equality gets us one step closer. And then lastly, we need to divide both sides by 7. And again, that's our division property of equality. Now, you can write your answer in a couple different forms. Since we're not using calculators, we're not going to use a decimal form unless you happen to know that 1/7 is approximately 0.142857. Instead, we'll just write it as 15/7, or you could write it as 2 and 1/7 if you prefer the mixed fraction. I'm actually fine with either one. Alright, let's take a look at number 4. This time we're going to need to distribute on both sides of the equation. So here we go, 6x minus 15 equals 5x plus 20. So again, distributed on both sides. I like the idea of moving the variable to the left. Again, though, we do have that option. We could have moved the variable to the right. Moving it to the left maybe keeps us in our comfort zone a little bit more, and in this case has the added bonus of getting rid of the coefficient. Just leaves us with a 1x. So at this point we can just add 15 to both sides, and we've quickly solved for x. X is equal to 35. Alright, go ahead and pause and do these next two on your own. And I'm back, and I will work through these reasonably quickly here. Distribution tells us that 4x plus 8 equals 3x minus 15. Again, we'll subtract, moving our variable to either the left or the right side, your choice. And then finally we can subtract, and we have our solution. On number 6, just to mix things up a little bit, I'll actually move the variable to the right-hand side this time. So to undo the minus 2x, I had to add 2x. And now we're following the inverse order of operations. Add 12 to each side. You'll have 6x equal to 18. Divide by 6 so that your variable will be isolated. And you end up with x equal to 3. Alright, one application problem. My good buddy Dandruff is vacationing in Chicago. He wants to visit the Willis Tower and needs to take a taxi cab to get there. You can see the rates for the yellow cabs and the orange cabs. And we're trying to figure out at what distance would Dan be charged this same amount by either type of cab. So what we need to figure out is, well, what's our variable? What are we trying to find? Well, it says right here, at what distance would they be the same? So we're looking for a distance. So we're going to say that x represents our distance, which we're measuring in miles. Okay, so yellow cabs charge $3 plus 50 cents per mile. So we can just do 3 plus 0.5x. That's your yellow cab. The orange cab is $5 plus 25 cents per mile. So what we can do here is write it this way: 5 plus 0.25 times the number of miles. Now in the end, we're trying to find out when it would be the same. So that tells us to put an equal sign right there. All right, let's solve the equation. I'm subtracting the 0.25x from each side. We can then subtract 3. And then we'll divide by 0.25. Now dividing by 0.25 may seem a little bit tricky to you, especially when we're not using a calculator, but you can think of it in terms of money. How many quarters would go into $1? So in this case the answer is 8. And when I said $1, I probably should have said $2 since we're doing 2 divided by 0.25. So what we would say is, if Dan travels 8 miles, it would be the same cost for either cab. All right, this last slide I know you guys do not have on your notes. My apologies for that, but there was something important that I neglected. So go ahead and write these down. If you need to pause, pause. All right, so what we run into in these surprising slash strange equations, well, let's find out. Let's see why these are different. They look the same at first glance, but let's see what happens here. Number 8 first. 3x plus 7 equals, and let's distribute, 3x minus 15. So far, so good. No problems. All right, let's move our variable. We can subtract 3x from both sides, and all of a sudden it gets really weird because 3x minus 3x is 0. Just leaves us with 7 over there. And on the right, we have the same situation. 7 equals negative 15. Now, in the particular universe we live in, that cannot happen. And when we run into a situation like that, we just simply say no solution. All right, let's take a look at number 9 together. First, start by simplifying things. 4 plus 8x equals, and 5x plus 3x, we can combine our like terms there. We'll have 8x plus 4. We can subtract 8x. Again, it's kind of weird, isn't it? But notice the difference. This time we get 4 equal to 4. When is that true? Well, it's always true. We have a name for this. It's called an identity. The identity means essentially that what we have on the left side of the equation and the right side of the equation are exactly the same. So we aren't really solving, we're just confirming something. So those are identities. Why don't you pause real quickly and do 10 and 11. All right, so here we go on number 10. 5x minus 10 equals 4x plus 4 plus x minus 14. We need to combine our like terms. 4x plus x gives me 5x. 4 minus 14 gives me minus 10. Now you might recognize already the situation we're running into, but if you need to go further, you can. You can subtract 5x from each side. We have negative 10 equal to negative 10. And just like we saw in number 9, this is the identity situation. The two sides are exactly the same. All right, and then the last one, number 11, 3 minus 4x equals, and when we distribute, we'll have 8 minus 4x. We can add 4x to each side. Leaves us with 3 equal to 8. And as we all know, 3 and 8 are not equal, so we just simply say no solution. All right, guys, a couple of weird things for you to consider, but to sum it up, if you solve and your variables cancel each other out, you're going to get no solution or an identity. Just look at the numbers and see if the statements that are given are true. We'll see you later.